Welcome to this new video demonstrating the Hume knowledge graph and natural language processing capabilities. For today's demo, we are going to import and analyze research paper data. The goal is to create new relationships between the research papers in order to discover new insights. The first step is to create a schema. The schema represents your domain or your problem. We can create a new research schema where we define the representation of a domain, such as research paper authors, the papers themselves, and the information we want to extract from the research. Let's start by adding a person class, which has an icon, a color, and a name attribute. That person is the author of a research paper. The research paper itself also has an icon, a color, and a set of attributes, such as an ID, a title, and a text being the text of the research. Now, that research is about chemical components. It is an important part of a domain, and we want to make chemical components their own entities in a graph. We will now create a knowledge graph using that schema. We give a name to the knowledge graph. We select the schema and the graph connector. We now upload some research papers. I already have a data set prepared with some research in JSON format. I create a new data set. Upload some files. The next step is to declare how our JSON file will be transformed into our schema. It's very easy in Hume. You just need to drag and drop the fields of your JSON file into class attributes or relationship attributes of your schema. You also declare how relationships are created. Here, we declare that a person in the JSON is mapped to a research paper. As you can see, 2 notes and 1 relationship are highlighted. This really defines what is the information we know exactly with the structured data. The goal now is to declare how we want to analyze the unstructured data in the research paper text so that it becomes structured. Chemical components are extracted from the text and become their own notes in the graph. Research papers are then connected to the chemical components they use through the uses component relationship. In Hume, it's very easy to just select a relationship. Select the entity recognition model that you want to use. Here, we already have an entity recognition model available for chemical components. We select the property that we want to analyze here and what attribute on the chemical components class the recognized chemical component should be mapped to. As we can see, we have an empty graph. We can now start to import the data. To understand what happened here, not only it created research paper notes and author or person notes and the relationship, but it also applied natural language processing on the research paper text. Natural language processing is a task of analyzing text and annotating noun label, for example, via labels here, specific pieces of the text. We can see also that natural language processing can recognize named entities. Named entities are mentions of text that represent things in the real world. In our real world, things can be chemical components. However, generic natural language processing tools do not have the ability to recognize more than people, numbers, organizations, or location names. That is why it is very important to create custom models in order to recognize more than those generic entities. We can now see what our graph looks like. We can see that we have 13 research papers imported, with 13 authors, and we could extract 2 chemical components from those 13 papers. We can now see that TiO2 chemical component was correctly recognized from a research paper, but also extracted as a chemical component entity. Thanks to this, if we analyze our Neo4j graph, we can see that it created relationships, not only for the structured data, but also for the unstructured data.